Okay, so we're going to review the internal structures of the pig heart now. And unlike the video that covers the external structures, this is now a cut heart. Obviously, as you can tell, we have cuts here and here, as well as into the atria themselves. But additionally, this is a much larger pig heart, than much larger specimen than we had for the external view. And so again, in this particular case, it doesn't really matter about that so much, just wanted to point that out. This is a larger heart. It does actually make it a bit easier to see some of the structures internally, which is why I chose it. Okay, so again, I want to point out a couple of things. This is the anterior surface here that we're looking at, and I can tell that again by the depth of the coronary sulcus here and here, as well as the obviousness of the atria, forgive me, and my hand placement here, of the atria here, as well as the atrium here. Right? And also, we see that anterior interventricular sulcus here that helps demarcate right from left on the outside. Okay, so giving us a little perspective here. All right, so what we're going to do is we're going to open this up. We're opening up we'll open up the right atrium first, right? There's not a lot to see inside the actual atria themselves, right? So again, the flap on the outside is the actual auricle. And again, we're looking at the right side here of the heart. I realize that I'm skewing the position of the heart, but this is the right side of the heart. And as we open it up, the only structure that you can actually visibly see inside of the actual atrium of the heart are these branches, or they almost look like meat branches or ridges along the inside of the actual atrium here. These are called pectinate muscles, right? And we're going to see something very similar, but on a larger scale in the ventricles as well. But these are the pectinate muscles. And we see those pectinate muscles on the left side, or left atrium as well. So if I open up the left atrium here, we can see those a little bit more largely on the left atrium here. But again, pectinate muscles. All right. Now, opening up the right ventricle. Here, and again, this is a little hard for me to position and do this well, so I'm going to have to kind of lay it down a little bit so we can see. So forgive me in advance if it's not a perfect view of everything. I really wish it was. So we're going to go ahead and position this like this. So now I've got this right ventricle completely opened, and so this entire chamber here on the inside, this is the right ventricle. And we can see all these branches, very similar to those pectinate muscles, all along the edge here of the actual right ventricle. And I think this is the most ideal place to see these structures. So what I'm going to do is put this probe right in there, right? And so all of these branch-like structures here, these are all what we call trabeculae carni. And I'm going to face it a little bit better so the actual camera can see. Right, those are trabeculae carni. Right? Trabeculae carni translates into meat branches. So, ironically enough, they do kind of look like meat branches. All right, so now another structure that we can see here opening up the right ventricle is this flap structure here. Another flap structure all the way deep in there. You can see that moving here, and a third flap structure all the way in here. I hope you can see that deep in there. The probe is actually lifting. Let me get in there. That probe is actually lifting it. Okay, so 1, 2, 3. 1, 2, 3 flaps. These flaps make up the tricuspid valve. Right? And that separates the right atrium from the right ventricle. Now, looking at that valve, one of the reasons I can tell it's a valve, right, besides the obvious flaps here, is because of these strings that attach directly to it. Now, I want you to, for a moment, ignore this one, because this has actually nothing to do with the actual valve. But these strings here, for example, right, we can see those strings attaching directly to the flap. These strings are known as chordae tendineae. Another term for these is tendinous cords. Right, so these are the chordae tendineae, or the tendinous cords. And the bump right here, from which those chordae tendineae come off of the actual ventricle, or the wall of the ventricle, and attached to that flap. This bump here is known as a papillary muscle. And that makes a papillary muscle much more distinct from these areas here that look very similar, right? These are trabeculae carni, but they have nothing to do with the actual chordae tendineae at all. But this bump or ridge here clearly does, because we see those chordae tendineae radiate away from it. And again, just to point out some other chordae tendineae here, I'm lifting up some of these smaller versions of it here. You can see them kind of passing over the probe as I'm rubbing back and forth on them. There are more chordae tendineae. So there's a lot of chordae tendineae in here holding this valve in place. And the idea behind the chordae tendineae is that they act like anchors. And so when the flaps of the tricuspid valve get oriented backwards by the pressure building in the right ventricle, and they slam shut to not allow access into the actual right atrium, those chordae tendineae hold this flap in place and keep it from prolapsing back into the right atrium, thereby allowing backward flow from the ventricle into the atrium, which is exactly what we don't want. Okay, so that's the tricuspid valve. Now, I want to point out this structure here, this cord-like structure, which I can understand can very easily be confused with chordae tendineae. It looks like them, it's about the same size, right? But the key difference here is that notice that in no way does this string ever touch or have anything to do with any one of these three flaps, right? It's all by itself. This band, this structure, only found in the right ventricle, is known as the moderator band. And the idea behind the moderator band is that it moderates the stretch of the actual right ventricle. That is, it prevents the right ventricle from stretching too much with high blood volumes and or high blood pressure. Right, so it helps maintain the integrity of the right ventricle and protects the right ventricle. Okay, so that's the right ventricle. And before we move on here, I want to point out some accessory structures that are related to the right ventricle. In this case, any of the ventricles, any of the atrium, whatsoever, right? And we're going to cover first the outer tissue layer of the actual heart. So if you're looking at the outside of the heart here, and you can actually see the outside of the heart, you can see those landmarks that I talked about on the external view of the heart. You are looking at the layer around the outside of the heart known as the epicardium. Now, this has two names, unfortunately, because in anatomy, unfortunately, sometimes we do see multiple names for the same structure, right? So the epicardium is also otherwise known as the visceral pericardium. So I want you to know that those two structures those two names are actually synonymous. They mean the same thing. They're pointing to the same structure, and that is the outer lining of the heart itself. All right, now to look at another tissue layer here, I'm going to go ahead and open this ventricle again, and we see the kind of the meat structure or meat tissue on the inside of the actual heart wall itself. And this tissue here is known as the myocardium. Right? And every time you see the term myo, the prefix myo, you should think muscle, right? So this is the muscular part of the heart tissue. Last but not least, we have that tissue that's lining the inside of the actual ventricle itself. So I'm going to go ahead and position this again. Any of this tissue that lines the actual inside of the chamber, if I put this probe anywhere, or in this case, if I use the sharp probe here and just place it, let's place it up here so as not to confuse you, right? Let's say there, right? The tissue layer that this probe is passing through is known as the endocardium. Endo, E-N-D-O. So endocardium, or the inside lining of the actual heart. So those are the three tissue layers that you need to know for the heart. Again, you can see them in any chamber. So it's not just the right, for example, or the left. It doesn't matter in that case. It's a little easier to open up the right ventricle, so that way I can make it a little more obvious. Okay. All right, so additionally, some other structures that we see here. I talked on the external view about the pulmonary trunk here. And we can see the pulmonary trunk really well if I just go ahead and I open this up a little bit more broadly. And one, you see these flaps that I'm touching here and here And here, there's actually 3 of them. I know that third one is a little bit hard to see, but 1, 2, 3 here. These cusps are actually the cusps of the pulmonary semilunar valve, otherwise known as the pulmonary valve. So you may call it either one, right? But it's the pulmonary semilunar valve. That's the term I typically use, right? But these cusps make up the pulmonary semilunar valve. And you can see if this probe were blood and the ventricle were contracting and it pumps and forces this blood up and through, it's going to force that blood up and into, if we can see here, I've cut open the actual pulmonary trunk. It forces that blood directly into the pulmonary trunk. Right, so this helps give you a little context, being able to identify a vessel based on where it's coming from. Right? There's only one vessel that emanates away from or comes off of the right ventricle and takes blood away from the right ventricle, and that is the pulmonary trunk. Okay, so I'm going to remove this probe now, and we're going to go to the left side, or the left ventricle. Now, I want to point out on the right side, notice how thin this wall is. It's fairly thin, right? All things being said. Now, it's thicker than the atrium, obviously, because it has more work to do, but not nearly as thick as the left side of the heart. We can see how it's actually just so hard to actually open because of that. So this is the right side. See the left side of the heart. See how thick that is? That myocardium is so thick because this chamber must pump blood all the way out to the rest of the actual body. Right, so this ventricle pumps blood to the systemic circuit, or the rest of the organs of the body, right? So that's why the left side is so much thicker than the right. Now, to keep this open here, I'm going to just kind of lay it down a little bit, and I'm going to use my fingers to hold it open there, try to place them in such a way. Forgive me, this view might not be ideal. It is the best I can do. All right, so I'm going to rotate it this way. Again, we can say chordae tendineae in here. We can see the papillary muscles in here. The structure I want to point out on the inside, though, the one structure that you're going to be able to see that flap that I'm pointing to here. There's another flap right here that I'm moving. And this might be a little hard to see. Let me see if I can't do this. See that big flap in there that I'm moving? This is the bicuspid valve, right? There's the other valve. The other flap here is a little bit better here. There's the bicuspid here, right? So that's the bicuspid valve. It's, again, a little trickier to see, so I'm going to go ahead and point that to you so you can at least see it without my probe and my finger in the way. Right? But that's the biggest structure that you need to see on the left side of the heart is that bicuspid valve. All right. Now, going through some things on the posterior side here. I'm going to take my probe and go into this is the right atrium here. Right? So if I place the right atrium, or I place the probe down to the right atrium, which I'm going to do this with my finger first. And I come down here, you can see right in this depression here, this area here is actually also known as the coronary sinus. So that is a vessel seen on the posterior side of the heart that it carries all the blood from the actual heart wall itself, from the actual heart itself, back into the right atrium. All that deoxygenated, used blood into the right atrium to be recycled back to the lungs again. So that's the coronary sinus. And I'm going to keep sticking my finger through. So my finger was in the right atrium, and now it's coming downward. So this tip of my finger here, where my finger is wiggling here, this is the inferior vena cava. And now if I put my finger again in that right atrium, but I go upwards this time, we can see the superior vena cava is where my finger is now escaping from. So this is the inferior vena cava. We can see the thickness of the aorta a little bit better here. It is this enormous vessel here, so it's a little bit better on this view than it was on the actual external heart that I showed you, the pig heart that I showed you the external structures on. So this is the aorta here. So we can see that fairly easily. Again, we can see a much better view of that aorta here.